All right, so the most common way we get moles of something is to weigh out its mass, right? So let's take a look at our little chart from our textbook. And we have mass of A, and we want to get from mass of B, right? So mass of A is over here, mass of B is right there. And so we're going to follow this trend right here, right? We're going to go from some unit of A, in this case, mass of A. We're going to then go to moles of A, then moles of B, and then some other unit of B, right? In this case, both of these question marks are masses, but depending on the question, it might be, something else. So let's do an example. So here we have iron 3 oxide reacting with aluminum to form iron and aluminum oxide. This is a thermite reaction. It's very exothermic, looks very cool. So if you want to see a cool reaction, Google thermite reaction. So instead of saying moles of something and moles of something, now we're just going to switch it up to mass of something. So we'll say you have 2.00 grams of Fe2O3. How many grams of iron can I get? Right, so it's the same thing we did before, but just slightly different. Of course, make sure your equation is balanced, which if I add that 2, everything should be good from there. So again, here we're going to start off with grams of A because that's what we have. We're going to then convert that to moles of A. Remember, our goal is always get to moles of A, and then use our stoichiometric coefficient to get to moles of B, and then turn moles of B into whatever we want. In this case, it's going to be grams of B. If we think how we're going to do all these conversions, moles of A to moles of B, that's going to be our stoichiometric coefficient from our balanced chemical equation. And then going from grams to moles is something that you should have mastered at this point. We're just going to use the molar mass of the two components. So again, I'll start off with a thing that's not a conversion unit in our question, and that's the 2 grams of iron oxide. So 2.00 grams of Fe2O3. And then if I want to go from grams to moles, I need to use the molar mass. So you can use a periodic table to calculate the molar mass, or you can be like me and just use Google. So according to Google, iron oxide weighs 159.69 grams per mole. My grams and my grams cancel out. Now I'm at moles of iron oxide. Now that I'm at moles is when I can use my stoichiometric coefficient. Note that you cannot use the stoichiometric coefficient when you're at grams because the equation always refers to moles. So then we're going to use our stoichiometry up here. And what we notice is that for every 1 iron oxide, I get 2 irons out. So then I'll have 1 Fe2O3 here, and then 2 Fe up here. The iron oxides cancel out with one another, and now I'm at moles of iron oxide. Well, I don't want moles of iron oxide. I want grams of iron oxide. How do I go from moles to grams? Well, I use the molar mass. And again, we are just going to cheat here and ask Google, although this is just a pure element, so you just need to look at the periodic table. So I have 55.845 grams per mole, right? The moles goes down on the bottom. That way the moles and the moles go ahead and cancel out. Now the units I'm left with are grams of iron, which is exactly what I want. Now I just go ahead and do the math. 1.40 grams of iron is what I get at the end. And so if you think about this conversion, right, make sure that you show your work super nice and neatly like so, and then think about how this relates to what we did down here, right? We went from grams to moles, grams of A to moles of A using the molar mass. That's what we did with that section right there. And then we went moles of A to moles of B. That's what we did with that conversion right there. And then finally, we went from moles of B to grams of B using the molar mass. And that's what we did right there. And we end up with 1.40 grams of iron. Now, the main thing you need to do here is practice, right? Don't just watch videos. It's going to cause you to overestimate your ability to do this. So make sure you do some practice. At the minimum, you need to do the work-alongs. If the work-alongs are very easy and you get them done in a couple minutes, that tells you that you're probably pretty good to go. You can go onto the homework check, and if you get those correctly, you're probably good to go. If you're struggling with those, then you need to use the extra resources or stop by office hours. But this is a skill that we need to master, and we need to master it ASAP. And if you don't, it's just going to make your life so much harder, and you're going to end up hating chemistry because you didn't build that solid foundation.